All right, I think the last time I was talking about Dolores Basin, which is a feature on Mercury that has been seen by what's called the Messenger spacecraft was in orbit many, many years ago around Mercury. Anyhow, the Dolores Basin is such a great impact that let's say it's over here. Um, you can actually see evidence of the impact on the other side of the planet. So this impact was so great that it almost broke Mercury apart. It was that intense. It was just barely able to keep itself together upon this impact. Remember, the early part of the solar system, there were lots and lots of impacts. This is a you know but by the way, every time you see craters on a body in our solar system, that is showing impacts. No, the craters generally, the craters that you see on different bodies in the solar system are usually small. But this one with Dolores Basin was an extremely large um, collision. Now Venus. Okay, so let's go over Venus. Of course, is it's almost the same size as the Earth. So here's one of the things. This is the first planet that we come to that has a very thick atmosphere, and it's a really thick. It's about 90 times the density of the Earth, or the Earth's atmosphere. Okay, so the Earth's atmosphere, of course, one atmosphere. So if you were on Venus, which you don't want to be, it's a terrible world. The atmospheric pressure would be 90 times that of the Earth, or, at the Earth at sea level. All right, so it's composed mostly of carbon dioxide. It's an extreme blanket. You might recall, of course, that carbon dioxide is a greenhouse gas, and on Venus, it's a greenhouse gas that has on steroids, if you will, because what's gone on Venus is it's a runaway greenhouse effect. That's a good way to describe it. The surface temperature of Venus is hot enough to melt lead. Right? So you don't really want to be on the surface of Venus. All right, so let me. It says that there's volcanic activity. We've never actually seen any volcanoes going off on Venus. We see evidence that there was volcanic activity on Venus, and in the relatively recent past. And what I mean by that, of course, is within the last few million years. That's relatively recent in terms of the entire age of the solar system of Venus, which is 4.5 billion years. All right, so let's see what else do we know. So the clouds are so thick on Venus that we can't actually see the surface of Venus. What we did is we've sent spacecraft that have orbited Venus. One was called Magellan, and let's see, what's the other one called? There's another one much more recent than Magellan, and it took unbelievably. I think it's called the Venus Express. It took unbelievably accurate measurements of Venus. It orbited for a long, long time, and used radar. All right, so it gave us radar images of the surface of Venus. Venus has mountains. They are smaller than the Earth's mountains. And one of the things that I always find interesting about Venus is the features on Venus, or most of the features, not all of them. Most of the features on Venus have been named after women, either mythical women or actual women. Like, for example, there's a region on Venus named Margaret Mead. There's another one called Aphrodite Terra. and I think another one called something about Cleopatra and stuff like that. So there's a lot of features on Venus that have female names, or either actual females or mythical. All right, so what else? It's extremely hot due to this runaway greenhouse effect. Um, recently, recently in the upper clouds of Venus, there is something going on that needs a little further investigation. Um, and there are some scientists who feel that well, let me describe what was discovered. There is some absorption in wavelengths that we how can I describe this? So there's some evidence that there might possibly be microbial life in the upper atmosphere of Venus. Now there's a big question mark there. Whether that does, there's no confirmation of that. Still has to be investigated in more and more detail, and we'll probably have to send a spacecraft there to specifically investigate that. I don't know of any at this time of taping this. I don't know of any spacecraft that's getting ready to go on a mission to Venus to verify whether the clouds actually have microbial life. I mean, if there is so it has to do with the light that comes into that hits the upper atmosphere of Venus, and it's absorbing certain bands of the electromagnetic spectrum that cannot be explained without without thinking about some kind of living organism that's absorbing those particular frequencies. So I mean, it still remain. There could be some completely non-living reason for this, but we just don't know what it would be. I mean, nobody's saying that there's definitely life. No one's saying that, but there's a possibility. So here's the first place. Besides, of course, our planet Earth. I mean, this is one of the grand questions that humanity has been asking for a very, very long time. Is there life elsewhere in the universe? And of course, there might be life right next door. I mean, that's why we're spending so much time looking at Mars, right? I mean, we're spending all this money sending spacecraft to Mars to see if there was, in fact, ancient life on Mars, because Mars, as we're going to see, was very similar, at least in the early days of the solar system, was very, very similar to the Earth. All right. Of course, here's the Earth, and we were just talking about. The Earth exists in what's called the habitable zone. It's also known as the Goldilocks zone. So that's this green region around the sun. Basically, what this region is where liquid water can exist. So notice the liquid water can exist, right where the Earth is, and all the way out to Mars. In fact, just a little bit beyond Mars. In fact, we've seen evidence of liquid water on Mars, not like an ocean or something like that, just a little bit of evidence of, maybe some frozen water that melted or something like that on Mars. There's no evidence of water on Venus, for example, because it's just way too hot, and Mercury doesn't even have an atmosphere, so there's nothing, there's no hope of finding any kind of life on Mercury. All right, that's the Earth. We've already studied. I mean, we spent most of this semester studying the Earth. All right, so Mars, of course, the fourth planet from the sun. It is also in the habitable zone, right on the edge of the habitable zone. I mean, so what that means, of course, is more than likely any water that's on Mars is frozen, although it can turn to liquid. All right. So it's around half the size of the Earth. Its atmosphere is extremely thin. So remember how I mentioned that the Venus is about 90 times the density of the Earth's atmosphere. Well, Mars is kind of the opposite way. It's only about 1% the atmospheric pressure that we find on the Earth, and so about 95% of it's very, very weak atmosphere, but about 95% of it is, of course, carbon dioxide. There is oxygen, but it's only 0.15%. Let's see. The planet thin atmosphere reducing temperature. Yeah. The equatorial temperature ranges from about 30 degrees Celsius, which that's actually pleasant. 30 degrees Celsius to very, very cold. Negative 130 degrees Celsius at nighttime. And of course, there's been exploration of Mars since the 1970s, right? We landed the Viking spacecraft. There were 2 Viking spacecraft that landed on Mars, and then that was in the 1970s, and then since then there have been dozens and dozens of spacecraft that have landed on Mars. And nowadays we send rovers. The last rover that we sent, which was called what was that one called? I think it was Perseverance. The Perseverance rover had I think I'm getting the name right. It had a helicopter. It's just more like a drone, actually. But it's sometimes called the Mars helicopter, and it flies not too far from the rover and takes pictures. And as of the taping of this video, it was still operational. All right, but of course, it won't keep going forever. All right, let's see. There's a Mars rover right there. I don't know which one this is. Probably Curiosity. That looks like the Curiosity rover. All right, so the first 2 rovers were called Spirit and Opportunity. They have since died, if you will. In other words, they can't be charged. They're just sitting there on the surface of Mars now. But Curiosity and Perseverance are on Mars. The Spirit and Opportunity rovers gave us lots and lots of information about Mars. One of the things that we can tell is that there was in the very early stages of Mars there was liquid water on the surface of Mars. All right, we find the largest peak in the entire solar system, the largest mountain, called Olympus Mons. It's way bigger than Mount Everest on Earth, and that's because, of course, the gravity on Mars is only about 1/4 the gravity on the Earth. So mountains can be much taller. Let's see the other planets. So now we get to the outer planets. These are also known as the gas giants. They tend to have a very low density. They're much larger than the Earth. they're much wider. They're spaced out more in